A-level chemistry quick test video on organic reaction mechanisms. So the question's on the screen. If you want to pause the video, have a go and then play on for the answers. Okay, so the first part of the question, we've got to come up with the products for the reactions. Well, I'm just going to write the reaction equation and then we'll get the product from that. So the first one, we've got an alkene effectively reacting with chlorine. So we're going to get an addition reaction taking place where the chlorine is going to add across where the double bond was. So we're going to get that. So for the second one, we've got to bring in the information that I've highlighted there. The methyl group is a 2,4 directing group. So there are actually two possible products. So I'll go for a split arrow instead. Okay, so we'll go up here with the 2 chloro product. So methyl group's going to stay on, but we're going to get a chlorine there, and that would be HCl as the other product. And the other possible product's obviously the 4-chloro option, and would get HCl again. So we'll tackle this bit now, explain why a halogen carrier catalyst is needed for one of the reactions. So the reaction that needs the halogen carrier catalyst is the second one, and that's because in this benzene ring we've got a delocalized ring of pi electrons. So the electron density is quite low as a result of that, because they're shared between all 6 carbon atoms. It's unable to polarize the chlorine molecule, and so therefore to get this reaction to go you need either an AlCl3 catalyst or FeCl3. So I'll write up what I said just underneath there now. So something like this would be fine. So in the benzene ring the pi electrons are delocalized. Very important word there, and that means the low electron density of the pi electrons means the benzene ring is unable to polarize the chlorine. Had you been asked about this one as well, sometimes they ask you to compare the reactivities of things like this. You just say the sort of reverse of that. So here we've got localized pi electrons because they're shared between just those 2 carbon atoms. That gives a higher electron density for the pi electrons, and that means that they can polarize the chlorine molecule, so it doesn't need the catalyst. So if we move on to the mechanisms now, so I'll deal with the alkene one first. Okay, so the first thing we need to do is show the dipole across this bond, because as the chlorine gets closer to this localized pair of pi electrons, we've got polarization taking place in the chlorine molecule. So this end would be slightly positive, this end slightly negative, and that means that the pi electrons can come out, they're attracted to the slightly positive chlorine, and that's going to repel the electron pair in that chlorine bond onto the delta negative chlorine, and that is heterolytic fission. So that's going to give us an intermediate, so a carbocation in effect. I'll put the chlorine on there. I could have put it on this carbon, but because I've put it there, that means I need a positive charge on that carbon, and this chlorine here would be a Cl- ion. Put a lone pair on there because I can then draw a curly arrow from the lone pair onto that positively charged carbon, and that's going to give me my product. And just to round off, we'll give the name of the mechanism. You can see there I've written electrophilic addition. Okay, for the next one I'm going to use the AlCl3 catalyst, and I'm going to make the 2-chloro product. Obviously you could have made the 4-chloro. The question hasn't specified which one you've got to make, so either would be fine, and obviously you could use an FeCl3 catalyst as well. Okay, so the mechanism starts by reacting the halogen carrier catalyst, the AlCl3 in my case, with the chlorine. We make the electrophile Cl+ ion, and we also get an AlCl4- ion as well. So the next part of the mechanism, we take the methyl benzene and the electrophile we've just made, and a pair of electrons come from the pi electron cloud. So it's really important that you take them from the circle and not the hexagon. And that's going to, remember we're making the 2-chloro product, so I need my intermediate to have, we've still got the methyl group there. I'm going to show the hydrogen that was already there, the chlorine, and then for the partial electron cloud we keep it open between the 2 carbons where the attachment is. So something like that with a plus charge in. So that's the intermediate. And then we need to lose this hydrogen here. So we do that by a pair of electrons going back in to reform the pi electron cloud, and that's going to generate the product. So we get that. The hydrogen is now an H plus ion. And then the final thing is to reform that catalyst. So we take the AlCl4 minus ion, the H plus ion we've just made, and it reforms the AlCl3, and we get the other product of the reaction, HCl. And this mechanism is electrophilic substitution.